A company produces steel rods. The lengths of the steel rods are normally distributed with a mean of 261.5 centimeters and a standard deviation of 1.1 centimeters. For shipment, 28 steel rods are bundled together. Find the probability that the average length of a randomly selected bundle of steel rods is greater than 262 centimeters. All right, so we are told that we have these steel rods that are normally distributed. So I would definitely recommend beginning the problem drawing a distribution. All right, and then we want to indicate the mean of this distribution and the standard deviation. Now, the mean of this distribution is 261.5. The standard deviation is 1.1. But we are working with a sample of 28 steel rods. So we're going to take that standard deviation and divide by the square root of 28. So that makes this a sampling distribution, but it doesn't really, it's not that different from the process that we do with just normal distributions. As long as we account for the standard deviation, that's all we need to worry about. So the mean of 261.5 is right here. We're looking for steel rods that are 262 centimeters or greater. So I would use the normal CDF function and give it my inputs. The lower bound is 262. The upper bound of the shaded region is infinity, so I'm going to use e to the 99th power for that. So 1 times 10 to the 99th, that is. And the mean is 261.5, and the standard deviation is 1.1 over the square root of 28. Now, the calculator will handle this for me. So if I hit second and vars, that'll bring up the distributions menu, come down to normal CDF, and I can just start typing it in exactly as I see it. So second and comma gives me the E, then 99, 261.5, and 1.1 divided by the square root of 28. I'll just press enter, and I get my probability 0.0081. And some of you may have seen a menu come up when you did the normal CDF function, and that's okay. It's actually a helpful thing. It just allows you to see all the different inputs to normal CDF, so you don't have to remember them or what the order of them is. You just simply type them in and they're all on the same screen, which is really nice because in the other mode it scrolls off screen. Now this is only available to later model TI-84s, so you might not have this, but if you do, it's helpful but not essential. And you can just type in 1.1 divided by the square root of 28 right into your standard deviation. And it doesn't calculate it, but when you paste, it will put it right into the function as you need it and come up with the same answer, no problem.